This conference will now be recorded.
In today's session, we'll try to understand one more important service in AWS, that is EKS. So we already discussed various services in AWS. We started understanding about EC2, EBS, S3, ELB, VPC, auto scaling group. Later we discussed about RDS, DynamoDB. And in today's session, we'll try to understand one more important service, that is EKS. So first of all, what is EKS? The full form of EKS, Elastic Kubernetes Service. Elastic Kubernetes Service. So what is this Kubernetes? First of all, Kubernetes is a container orchestration software. Kubernetes is a container orchestration software. You can set up Kubernetes on your own, in your own on-premise environments, in your own on-premise environments. We call it as a bare metal Kubernetes clusters. So within your own on-prem environment also, you can set up your Kubernetes cluster, but that is self-managed Kubernetes cluster. That is self-managed Kubernetes cluster. That is self-managed Kubernetes cluster. So in case you are trying to set up on your own, you need to manage everything. You need to manage the availability, scalability, fault tolerance in the Kubernetes, right? You need to install required Kubernetes components, and you need to manage the availability, scalability of the Kubernetes control plane. EKS, it's a managed Kubernetes service. Instead of you set up the Kubernetes cluster, instead of you operate and maintain the Kubernetes, AWS will manage Kubernetes for us. So that is a service, Kubernetes as a service. So EKS, Elastic Kubernetes Service, is a fully managed Kubernetes service. So Kubernetes is a container orchestration software. Using Kubernetes, you can deploy your applications as a containers into the cluster. Kubernetes will manage the applications in the form of pods and its containers. But instead of you set up the Kubernetes on your own, let AWS to create and manage the cluster for us. That is EKS. EKS is a fully managed Kubernetes server service basically. EKS is the best place to run. EKS is the best place to run Kubernetes applications because of its security, reliability, and scalability. EKS is the best place to run Kubernetes applications because of its security, reliability, and scalability. EKS can be integrated with other AWS services such as CloudWatch, auto scaling groups, IAM, VPC, ECR, ELB, all those other services. EKS can be integrated with other AWS services such as ELB. You can create a services of type load balancers for whatever applications you are deploying in a EKS cluster. So ELB support is there. ELB service is already integrated with EKS. And you can use CloudWatch for logging, like your control plane logging can be integrated with CloudWatch, and you can integrate with auto scaling group, that node groups, EKS node groups, whatever node groups you are going to add for your cluster, that is internally a auto scaling group again. And access to the EKS cluster and other AWS resources can be managed via IAM. And again, when you create a EKS cluster, you are going to isolate your Kubernetes nodes, into a VPC. So EKS can be integrated with various other services such as ELB, auto scaling group, CloudWatch, IAM, VPC, and ECR, like that. So EKS makes it easy. EKS makes it easy for you to run Kubernetes on AWS without needing to install and operate and maintain your own control plane. You no need to install, you no need to operate and maintain the Kubernetes control plane, that control plane components, that master components. So EKS has a fully managed control plane. EKS has a fully managed control plane. Fully managed control plane in the sense the Kubernetes control plane, that Kubernetes master components, the Kubernetes control plane, that is Kubernetes master components in the master node, the Kubernetes master, that control plane component like etcd, API server, scheduler, control managers, that master machine components, that master node or control plane node is completely managed by AWS. So EKS has a managed control plane. EKS provides a scalable, highly available control plane. EKS provides a scalable, highly available control plane that runs across multiple AWS availability zones. That control plane is nothing but a master. Kubernetes control plane is nothing but a master. In master, you have Kubernetes components like etcd, API server, scheduler, and control managers. So EKS provides a scalable, highly available, managed control plane that runs across multiple availability zones. And Amazon EKS service automatically manages the availability, scalability of the Kubernetes API servers and etcd. So EKS manages the availability and scalability of your control plane, that API server and etcd. And EKS EKS runs the Kubernetes control plane. EKS runs the Kubernetes control plane across three availability zones, kind of a three masters, kind of a master nodes, three master nodes for each Kubernetes cluster. EKS runs the three master nodes for each Kubernetes cluster in a three different availability zones in order to ensure the high availability. And also EKS can automatically detects and replace unhealthy master instances. So this control plane components, this control plane nodes, master nodes is completely owned by AWS. You don't see master nodes in your account. These are completely owned by AWS. You don't see these master nodes in your account. Once you create a EKS cluster, you are going to add worker nodes, basically a node group. You are going to add a node group, that worker nodes, to that EKS cluster. Then you can start deploying the applications in the EKS cluster. So EKS is a fully managed Kubernetes service. If you see AWS EKS, the official documentation, AWS EKS official documentation, if you see EKS, right? It's a fully managed, it's a fully managed control plane. It's a fully managed control plane. AWS is managing the control plane for us. AWS is managing the control plane for us. If you see the documentation, let me go to the documentation. Let me search the documentation for EKS. If you see the EKS documentation, if you see the documentation of EKS, let's understand what is this EKS basically. Again, I told already. So EKS, it's a managed service that you can use to run Kubernetes on AWS without you need to install and operate and maintain your own Kubernetes cluster, control nodes, control plane or nodes. So EKS is integrated with other services, as I already told. EKS is integrated with other many services to provide scalability, security for your applications, like ECR for container images, elastic load balancing for load distribution, IAM for authentication, VPC for isolation, right? And EKS will run and scale the Kubernetes control plane across multiple availability zones in order to ensure the availability. and automatically control plane nodes will be scaled in, scaled out, and it will detect and replace unhealthy control plane nodes, master nodes. It's provide automatic upgrades also. It provides automatic upgrades also. How EKS works, right? You create a EKS cluster. How does EKS works? You just create a EKS cluster. You add a worker node. You add a worker nodes to that EKS cluster. Deploy a compute. Deploy compute in the sense you add a node group. You add a node group. You add a workers to that EKS cluster. Then you connect to the EKS and run your applications. Run Kubernetes applications in that EKS. So you just create a EKS cluster in AWS and deploy a compute. Compute in the sense add a node groups. Node group is nothing but worker machines. Add a node group to that EKS cluster, then connect to the cluster and start deploying your applications. So if you have to run EKS on AWS without you need to install and set up and manage, you can create a EKS cluster and start deploying the applications. So control plane is managed by AWS. And before you need before you create a EKS cluster, let's understand what is required for you to create a EKS cluster. You need a dedicated VPC. You need a dedicated VPC for EKS cluster. In real time, you may not create EKS in a default VPC. In real time, you may not create EKS cluster in a default VPC. For what reason we will not create EKS cluster in a default VPC? You should already know, you already know what is default VPC. For what reason we should not, or it is not recommended to create a EKS clusters and EKS worker nodes in that default VPC for actual environments like dev, prod, QA? Why? Network security. Network security. Network security. Why network security? Because the default VPC, default VPC, default VPC, it is not about ports. If in default VPC also, excuse me, in default VPC also you can open whatever ports you want to open. Nothing will stop you to open only whatever ports which is required. It is not about ports. It is about connectivity, network. Is the default VPC has all the subnets as a public subnets, whatever you already have the subnets in the default VPC, yes. So if you create a EKS cluster and it's a worker nodes in that default VPC, is that nodes, is that cluster is accessible over internet also, public networks also? Yes. So that's why in real time you are not going to create a VPC. You are not going to create a EKS nodes and EKS cluster in the default VPC because of the public subnets, publicly accessible. It is nothing to do with ports. You can block whatever ports you want to block also in default VPC. It is about subnets, public subnets. So you need to create a dedicated VPC for your EKS cluster and its node group. So AWS VPC also has some EKS has some network requirement again. So prerequisite before you create a EKS cluster, prerequisites an existing VPC with subnets that meet EKS requirements. So before you deploy a cluster, EKS cluster for a production use, we recommend that you have a thorough understanding of VPC and subnet requirements. So before you create a EKS, you should have a thorough understanding about the VPC and subnet requirements for EKS. So there is some requirements for EKS with respect to VPC. So what AWS EKS is saying for what type of VPC, what subnets is required like that, let's understand. When you create a EKS cluster, you specify a VPC and at least two subnets. When you create a EKS cluster, you specify a VPC, at least two subnets, that is at least. at least two subnets that are in two different availability zone. Because in the background, who is going to provision the master nodes, basically the control plane nodes? AWS. So if you select only one subnet, again that is in one availability zone, or maybe both subnets in the same availability zone, this control plane node will be created in that single availability zone only. Yes. So if something is wrong with that zone, availability zone, you may not have another zone where the master is available. So that's why when you create a EKS cluster, you should specify a VPC, at least two subnets that are in two different availability zones. Okay. And EKS specific requirements for VPC and subnets, this is one of the minimum two subnets is required in that VPC. That is minimum. And again, there are a lot of other requirements and considerations when it comes to VPC for EKS. When you create a EKS cluster, that VPC you specify must meet the following requirements. So VPC must have a sufficient IP addresses. The VPC must have a sufficient number of IP addresses available for the cluster or nodes, that other Kubernetes resources that you want to create. And if the VPC that you want to use doesn't have a sufficient IP addresses, try to increase the number of available IP addresses. You have a very big CIDR range. Okay. And one more important component here, right? The DNS, the VPC must have a DNS hostname and DNS resolution support. DNS hostname and DNS resolution support. If you guys remember when I explained AWS VPC, I told DNS hostname, DNS resolution. While creating a VPC, if required, can you enable the DNS hostnames option at the VPC preferences? That is required here. And the VPC must have a DNS hostname and DNS resolution support. Otherwise nodes, the Kubernetes nodes cannot register to your cluster. So at least the VPC should have sufficient number of IP addresses in the form of CIDR, and your VPC must have a DNS hostname, DNS resolution support for that. And also you should have a multiple subnets in multiple availability zones when it comes to VPC, right? And subnets, right? As I already told, when you create a cluster, Amazon EKS creates some network interfaces. Amazon EKS creates some network interfaces in the subnets that you specify. When you create a EKS cluster, whatever subnets you select, right? EKS will create a network interfaces in that subnets. These network interfaces will enable communication between your cluster, your EKS cluster, that control plane, and your VPC. So when you create a EKS cluster, you are going to select some subnets. In each and every subnet, EKS creates 2 to 4 elastic network interfaces in that subnets. These network interfaces enable communication between your cluster, that EKS, and between your VPC, between this VPC. So these network interfaces internally, this kubectl exec kubectl logs command, also internally this will use that network interfaces to communicate with that cluster. And right, make sure whatever subnets you are selecting while creating a VPC, you need to select whatever subnets you need to select while creating a EKS cluster itself, and that subnet should have at least minimum some IP addresses. The subnet must have at least 6 IP addresses is required for EKS only. At least 6 IP addresses is required for EKS only in that subnets. So they are recommending at least 16 IP addresses like that. So you need to have a VPC with enough CIDR range. VPC should have a DNS hostname, DNS resolution support, and your subnet should have at least some IP addresses. Create a subnets with bigger CIDR also, because EKS nodes and EKS cluster will use some IP addresses in that CIDR. So this is the requirement when it comes to network, VPC for EKS. And again, it is recommended to go with public subnets and private subnets for your EKS also. Public subnets and private subnets also. Why public subnets is required? Why public subnets is required? Suppose you are creating a service for whatever application you deployed in your Kubernetes cluster, you are going to create a service of type load balancer to access that application, which is deployed in the cluster. You are going to create a service of type load balancer. So that load balancer will be created in a public subnet so that the customers, the end users can reach that load balancer. From that load balancer, they can reach the Kubernetes nodes to access that application. So it is recommended to have a combination of public subnets and private subnets with that VPC and subnet requirements. So make sure you have a VPC. Make sure you have a VPC with enough CIDR. Make sure you have a VPC with enough CIDR, range, enough IP addresses, and make sure your VPC has a subnets, 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 right? At least some subnets with again enough I don't know CIDR range, available IPs. So make sure your VPC has some subnets, at least in 2 different availability zones, 2 different subnets. Even though you have something like this also sufficient, it is good. Maybe 2 also fine, but in 3 also okay. So make sure you have a private subnets. Make sure you have a private subnets. Make sure you have a private subnets, because you can create your nodes, your node group, that is worker nodes for your EKS. While creating a node group, you can select private subnets, right? Select like this. At least in 2 different availability zones, you need to have a 2 different private subnets like this for this basically worker nodes like this. And also make sure you have a public subnets also, because when we create a service of type load balancer in EKS, it has to provision the ELB. That ELB will be provisioned in the public subnets. So it is recommended at least something like this. Even though if you have something like this, fine. Even though you have something like this also in 3 different availability zone, in each and every availability zone, if you have something like this also fine. In each and every availability zone also, if you have something like this, this is also fine. In 3 different availability zones, one public subnet, one private subnet like this. And also make sure you have a NAT instances also. Make sure you have a NAT instances also in case these private servers, need to communicate with maybe various other AWS resources like ECR. Suppose you have images in the ECR. You can create a VPC private endpoint if you want to reach privately. Otherwise, this should have a NAT instances. This subnets should have a NAT instances and its route tables. So you need to have a VPC something like this. You should have a NAT also, NAT instances, something like this for each and every private subnet, something like this NAT. There should be a route to the NAT for these subnets, and you should have a public subnets. So you need a IGW also, and there should be a route. There should be a route to the IGW. There should be a route to the IGW for the public subnets. There should be a route to the IGW for public subnets. You should have a VPC, maybe with the 2 availability zones. In each availability zone, one public subnet, one private subnet also fine. Otherwise, 3 availability zones also fine. It's up to you whether you want to have a 3 availability zones public subnets and private subnets, or in only 2 availability zone public subnets or private subnets. It's up to you. But this is the required VPC, you need to have a VPC with required components before you are creating a EKS cluster. Is everyone clear? The VPC requirements when you create a EKS. Is everyone clear? The VPC requirements for your EKS, EKS cluster. When you create a EKS cluster, you are going to select a VPC. What and all things are required in that VPC? You should have a VPC with like private subnets and public subnets like this. VPC in the sense without routing table, how it will work, Chandra? Again, I cannot explain like again VPC, right? Without IGW, how it will become public subnet? How it will become private subnet? I'm saying private subnet, public subnet, which means there should be a route table. You need to create and add the entries. So we already discussed VPC and its components, but I'm saying EKS requirements in the VPC. What EKS is expecting in the VPC in which you are trying to create a cluster. Clear? Now, I already created all these things. If you guys remember, did I already created all these things when I explained demo VPC? But as of now, I don't have a two different NAT gateways. Both private subnets are attached to the same NAT gateway in the same route table. That is fine. But do I already have this requirement? I mean to say, do I already have a VPC which is satisfying the EKS network requirements? Yes. So we already have a VPC satisfying this network requirement. So I created a one private route table. In that private route table, I associated these two subnets with this NAT. There is a route, and I already have one route table, one more route table, that is public route table. In the public route table, I associated these two subnets. And there is a route to the IGW. So this is already done. So I'm going to use same VPC. But if you don't have a VPC, can you create a VPC as per that your requirements? You already know VPC, how to create a VPC, subnets, route tables, all those things. So you can create, but I already have a VPC. Let me go to VPC section. Let me show that this demo VPC. This demo VPC. This demo VPC. I created one VPC. This demo VPC. This one I am talking about. This one, not about this. Let me delete this. This is old VPC. Let me delete this. I don't need this VPC anymore. So if you see this VPC, this demo VPC, I have given the CIDR like this, and this VPC, if you guys remember in this VPC settings, I already enabled DNS hostname and DNS resolution. This is one of the requirement for your EKS. They told that is one of the requirement for EKS, right? In the VPC, the VPC should have the VPC must have a DNS hostname, DNS resolution support. If this is not there, the nodes, the worker nodes cannot register to your EKS cluster. So this is already there. DNS resolution, DNS hostname in that VPC. And I have enough CIDR, at least 256. And is that VPC has subnets? Recently, AWS has enhanced their UI. AWS has enhanced their UI. I can see by here itself when I go to VPC like this. If you see, they're giving here. When I go to this resource map tab, if you see, they're saying how many subnets are there in 1B availability zone. In 1B availability zone, there is 2 subnets, and 1A availability zone, there are 2 subnets. And if you see the route table, right? If you see the route table, this subnet and this subnet is associated with this route table. That is, we have a route to the IGW. That is, we have a route to the IGW, right? And these two subnets are associated with this route table. There is no route to the IGW, but there is a route to the NAT, right? So otherwise, you can go to subnets and route tables also. You can see there are 4 subnets: this one, and this one, and this one. These are the 4 subnets which are created for that VPC, which are created under that VPC in 2 different availability zone, right? And there is a route table. There is a route table, one public route table where I have a route to the IGW, and these subnets are associated to in that route table, public subnets. And there is a private route table. This is 2 subnets associated in this route table where I have a route only to the NAT but local. So I have something like this. Now, is my VPC requirements are meeting for me to create a EKS cluster now? That VPC? Yes. So let's proceed for EKS cluster. So the first one, you should have a VPC. You should have a dedicated VPC for your EKS cluster, but there are some VPC requirements. I have just explained all those things, and I already have a EKS cluster. Vijay Lakshmi is saying voice is breaking. Is it for everyone? I don't think so, because I am having very good internet speed. Guys, it is only for you. Check from your side. I don't see any problem. I am having very good bandwidth, the network bandwidth, internet speed. I don't think it's a problem from my side. Okay. So let's go and create a VPC. VPC is already there. Let me go to EKS. Let me go to EKS. But before creating a EKS cluster, I am going to create one IAM role. Before I create a EKS cluster, I already have a VPC, so I am not creating a VPC. I already have a VPC, so I am not creating a VPC. Next, I'll create a IAM role, because when I create a EKS cluster, that EKS requires permissions to the AWS resources. That EKS requires permission to the AWS resources, because EKS is internally managing lot of things. So EKS requires access to the EC2 service. EKS internally requires permissions to the ELB. In case EKS has to create a service of type load balancer, EKS will internally make a request to the AWS to create a load balancer. So EKS requires permissions to manage various other AWS resources. So there is some concept called IAM. So we are creating one IAM role with some policies. We are creating one IAM role with required policies. We are creating one IAM role with required policies, that is EKS cluster policy. This IAM role I will create when I create a cluster, that EKS cluster. So first let me go to IAM. Let me go to IAM. Here, let me type IAM. Let me create a role, one IAM role. Let me go to roles. Let me go to roles. Let me create a role. Let me create a role. Let me create a role, IAM role. Let me create a IAM role. For which service you want to use this IAM role? First, when you go to IAM, you need to create one role, and you need to select for which service you are planning to attach this role. So I am not going to attach this role to EC2. I am going to attach this role to the EKS. So go to this use cases for other services, search with EKS here, select this one. Select EKS here and select this EKS cluster. select this radio button, EKS cluster. It will allow access to other AWS resources that are required to operate clusters managed by EKS. So this EKS, I am creating one IAM role by selecting this policy. So it will allow EKS to manage other AWS resources. So let's select this. Let me click on next. Now this policy is attached. If you see, there are various permissions, right? EKS requires permissions to create auto scaling groups, permissions to create a EC2 volumes, attach volumes, because if you guys are using dynamic storage like EBS volumes for your pods, and EKS requires elastic load balancing permissions to create a permissions load balancers. So we attached that, we selected that one basically, that EKS cluster policy. So this is all the permissions EKS is required. Let me attach a, let me give a role name, EKS cluster role, like this. Let me give the role name. Let me create a role with that policy, EKS cluster policy. This IAM role I will use when I create a EKS cluster. So I created a IAM role with this option for EKS cluster. So let me create a EKS cluster. Let me go to EKS again, EKS, Elastic Kubernetes Service. Elastic Kubernetes Service. Now I don't have any clusters as of now. I don't have any clusters as of now. Let me click on create cluster. Let me click on create cluster. Let me give some name, whatever, demo, EKS, something like this. In real time, you will give your project name, your use case name, like that. So let me give demo EKS, and what version of the Kubernetes you want to use. I am going with the default, that is 1.24, and let me click on next. So networking, select the network, select the VPC to use for your EKS cluster resources. So I am not going to select default VPC. I am going to select this demo VPC. I am going to select the demo VPC. But when you are creating a EKS cluster, you need to select the subnets. Choose the subnets in your VPC where the control plane will create a network interfaces. The network interfaces. Select the subnets in your VPC where the control plane will place the network interfaces to facilitate the communication with your EKS cluster. So when I am creating a EKS, you need to select the subnets in which you want to create network interfaces. I am selecting everything. But once the EKS cluster is there created, you can't create a network interfaces for communication to the control plane. So while creating a cluster itself, I am selecting all the subnets which is there in that VPC. This is just creating a network interfaces to facilitate the communication with your cluster. So I am selecting all these 4 subnets, and security group, leave this security group. If you want to select this security group, you can select the default security group, otherwise leave here. So automatically it will create one security group. Leave this security group here, and here public and private endpoint access, cluster endpoint access. So cluster endpoint access in the sense API server endpoint. So API server, you already know Kubernetes, right? You should know Kubernetes. I'm not teaching Kubernetes again. You should know Kubernetes. If you know Kubernetes concept, if you want to create or update or delete any resources in the cluster, you want to deploy any application for any developmental or administrative or developmental task in your Kubernetes cluster, you are going to use a CLI, that is kubectl. So kubectl will contact whom internally? Basically the API server. So that API server endpoint, access, what type of endpoint you want for that API server. If I select public endpoint, right, the API server is reachable from internet also. The API server, you can talk to the Kubernetes API server from other VPC, other networks also, like that. Other VPC, other networks also, like that. So if you select a public and private, you can reach API server from internet. The cluster endpoint is accessible from outside of your VPC, but worker node traffic to the endpoint will stay within VPC. If you select private, right, you can't reach API server from a different VPC, public networks. You can't reach the API server. If you want to talk to the API server, that Kubernetes client machines also should be part of private network. In real time, you are going to select the private only, unless until your employees like a developers or DevOps guys or your CI/CD tools are not part of the private network, they can't communicate with your EKS cluster for deploying applications or updating applications. In real time, you will select private only. Now I will select this public and private endpoint access. So I can reach the EKS from other VPCs also. I mean to say that API server from other VPCs for deploying the applications to the cluster. I'm choosing this cluster endpoint access as public and private for now. Now, logging, control plane logging. So Kubernetes control plane is completely owned by worker node traffic. Means if you know the Kubernetes concept, Kubernetes has a workers. If you know the Kubernetes concept, Kubernetes has a workers. The workers will communicate with master privately. That is what the meaning of worker node traffic. Workers will communicate with your master privately, but you can reach the master publicly. That is API server. You can reach API server publicly. Workers in the sense, even if you know Kubernetes, there is a concept called Kubernetes workers. That workers will communicate with masters, or worker to worker communication will stay within that VPC privately. That is what the meaning of that statement. Now, when it comes to control plane logging, so it will send the control plane is completely owned and managed by AWS only. But I want to know what is happening inside API server, what is happening inside scheduler. So you can't see master nodes in your account. So if you enable this control plane logging, EKS will send the API server logs, scheduler logs, control manager logs, audit logs to the CloudWatch. So you can query the logs from the CloudWatch if you enable the control plane logging. So this is very, very important, right? What is happening inside my Kubernetes API server, scheduler, control managers, audit logs, what is happening inside my cluster. So who is doing what within my EKS, who is deleting, who is deploying what. I need that audit logs. So you can enable all these control plane logging so that EKS will send the logs to the CloudWatch. From there you can query. So in real time, this is important. Okay. Let me click on next. And Kubernetes add-ons. We discussed in Kubernetes, you have a kube proxy, you have a DNS, service discovery in Kubernetes, that is DNS, and container networking interface, pod networking. Within your Kubernetes cluster, pod to pod networking, you should have some kind of a networking implementation, networking driver, CNI implementation. So AWS has their own CNI. For pod networking. So this Amazon VPC CNI will enable pod networking within your cluster. So in Kubernetes, we guys already discussed, right? So when you guys set up the Kubernetes cluster, we discussed about CNI, container networking interface. So there are a lot of implementations. We use the VNet, CNI. Otherwise, you can go with Calico like that, pod to pod networking. But here, AWS EKS has its own CNI, that is Amazon VPC CNI. These are the add-ons. By default, it will be installed in your EKS. Let me click on next. And versions, kube proxy version, DNS version, CNI version. I'm going with the default. Let me click on next. Now let me create a EKS. We are just creating a EKS cluster, just a cluster. Only control plane. With this only control plane is created. But there is no compute. There is no worker nodes for that cluster. Once this cluster is ready, once that control plane is ready, I can add a node group to this cluster. Once this cluster is ready, once this control plane becomes ready and active, then I can add a compute to this cluster. Compute in the sense, you can add a node group. That node group is nothing but one auto scaling group for your workers. So as of now, I can't add a node group because still it is provisioning. It will take up to 5 minutes also. So let's wait for that. Once this is active, then I can add a node group. Node group is nothing but one auto scaling group in the background for worker machines. But this control plane nodes, the master nodes, is it available in my account? Is it visible in my account? No, it is completely owned and managed by AWS. So who is taking care of provisioning the compute storage, and who is installing the control plane, managing the control plane for us? When I go with EKS, the Kubernetes control plane, AWS. So is everyone clear how to create a EKS cluster? First of all, the control plane EKS cluster. Once this is ready, then only I can add a compute. Compute is nothing but a node group, your worker nodes. So let's wait for some time. It will take any time between 5 minutes to 10 minutes also. We can't add a node group. We can't add node group that workers to this cluster unless until this becomes active. So I will wait for 5-6 minutes here. We'll continue after this becomes active, guys. We'll continue once this becomes active. It will take maybe up to 5 minutes. We'll wait for 5 minutes, okay. So we'll see. Still it is getting creating. Will get creating. Still it is getting created. Will get any impact old version service when we are working on latest version for those service? What do you mean by old version service? Are you talking about Kubernetes versions here? Old version service in the sense? Definitely, every version. Kubernetes is also one software, right? Kubernetes will release new features. Kubernetes will release new features, new enhancements, right? And some features, some API versions might be deprecated in the latest versions. You need to update your Kubernetes YMLs, your Kubernetes resources also, if you have to go with new features which is introduced in the new version. That is common for any software. If you know Kubernetes concept, you guys are creating a Kubernetes resources like deployment, stateful sets, replica sets, network policies, ingress rules, right? Every version they may deprecate something old, they may release something new also. If you need new features that is introduced in 1.25 but you are still using 1.24, can you deploy those Kubernetes resources with that new features if your cluster is 1.24 but the feature is introduced in 1.25? Definitely no. So you need a latest version for that feature, for that Kubernetes feature you are planning to use. Otherwise, You are using some Kubernetes version 1.24 and you are using some API groups. Sometimes some API groups might be deprecated in the new versions like auto scaling beta 1 like that. So if you are still using that API group as old API version group, that is deprecated in the latest one, if you apply, does Kubernetes will reject saying that not able to find a API with this group like that, invalid specification or invalid attributes? Definitely. That is nothing to do with EKS. That is Kubernetes. Kubernetes is also one software. So this EKS is using 1.24 Kubernetes version. That's it. Let's wait for this. Unless until this is active, I can't add a node group. It will take initially some time. This is not enabled. Add a node group. Node group is nothing but your worker machines. So let's wait this to become active. It will take any time, 5-10 minutes also. Wait. Meantime, let's understand the advantages with infrastructure as a code. Now I want to repeat, I want to replicate this type of infrastructure. I am using Kubernetes EKS for my application. I want to provision cluster like this. If I am manually creating, is it going to take a lot of time? Like whatever time it is taking manually, I need to create a VPC like this, I need to create a subnets like this. I need to create a NAT. I need to create a route tables, and I need to enable that DNS resolution host name. But same setup I need to set up for QA. But while doing QA setup, maybe I have done some small mistake as a human. Maybe I might have not enabled the DNS resolution or DNS host name. Might be I might have not created some route table. Might be I have not created some subnet. So is there a possibility for human errors? Even time taken is one problem. Is there a possibility for human errors when I am creating a infrastructure like this manually for deploying my EKS also? There is a chance for human errors. But can I define everything as an infrastructure as a code? The VPC, the subnets, the VPC, the subnets, the route tables, the NAT instances, and required IAM role, required worker node group, required EKS, all those things also? Yes. So instead of manually creating, you can create a EKS clusters, that is infrastructure provisioning. EKS is also one kind of infrastructure. You are going to replicate or reproduce this infrastructure, right? If I have everything as a code, can I run that code? Can I run that infrastructure code so that it will create a reproducible infrastructure and reusable infrastructure and consistent infrastructure? Via that infrastructure as a code, I can reproduce, I can recreate, or I can replicate, or I can avoid the human errors also. So I can create a EKS cluster using Terraform, that I will explain in Terraform sessions. I will share the code also that time. Instead of manually create a VPC, subnets, route tables, and NAT instances and IGWs required for a EKS, you can create a VPC. Within that VPC, you can create a EKS, IAM roles, worker nodes, whatever it is required for you to set up the cluster. But I am first explaining manually. In Terraform sessions, I will show this infrastructure as a code. And again, if I have to delete also manually, you need to delete in a proper order again. Manually again, if you want to delete manually again, you need to delete in a proper order one by one. But if I have an infrastructure as a code like Terraform, can I simply execute Terraform destroy so that whatever has been provisioned by that infrastructure code, that infrastructure as a code, is it going to destroy, like EKS, node groups, IAM roles, the VPC, subnets, route tables, NAT instances, everything also? Yes. So that is the advantage with the infrastructure as a code. So I will share the code also in the Terraform sessions for creating a EKS clusters along with VPC, subnets, route tables, all those things. So let's wait for some time. Still it is taking like 10 minutes. Provisioning is important. Once it is provisioned, right? Once your EKS cluster is provisioned, it is nothing to do with Terraform after that. Terraform will provision your EKS cluster and required VPC, subnets, route tables, and EKS clusters and node groups. Once the cluster is ready, can you connect to that cluster via your pipelines or manually via developers or DevOps guys, or maybe your pipelines also like CI/CD pipelines like Jenkins also, will it able to connect to that cluster and start deploying the Kubernetes resources for deploying that applications? Yes. So provisioning can be done via Terraform. The deployment can be done manually. The deployment can be done via automation, again via Jenkins pipelines. That is nothing to do with Terraform. So using Terraform, you can provision the required infrastructure resources like VPC, subnets, route tables, EKS. EKS is also one kind of a service in AWS. EKS node groups, IAM roles, like that. But once the cluster is provisioned via Terraform, your pipelines or your developers can connect to that cluster and start deploying their resources into the cluster. Okay. It's taking some time. Let's wait. Yeah, by this time it is ready. It took almost 10-12 minutes. Now my cluster, that EKS cluster, is provisioned, but there is no nodes, there is no worker nodes, there is no compute. So I will go to this cluster. I'll go to this cluster. I'll go to compute. I'll create a node group. Node group is nothing but one auto scaling group in the background. So let me add a node group. Some name I will give, node group. So before you create a node group, you need one IAM role for node groups also. Before you create a node group, you need one IAM role for node groups also. So before you create a node group, before you do this, you need one IAM role for node group also. Why IAM role is required for node groups, right? Your nodes also require some permissions. Your nodes also require some permissions to talk to the EKS service. Your nodes also require some permissions related to the networking, container networking, networking related permissions. And your node should have a ECR permissions, because suppose you have images in the ECR, Elastic Container Registry. It's a managed registry in AWS. It's a managed registry in AWS. It's a managed registry in AWS where you can maintain Docker images, the container images. If you are using those ECR images, your EKS nodes has to pull the images, so you need to grant the permissions. So that's why we need ECR permission. So if you have images in the ECR, if you have images in the ECR, and you are using those images to deploy into the EKS cluster, your worker node should have permissions to pull the images from the ECR. So that's why we are going to create one IAM role for worker nodes, and you are going to attach these ECR policies also. EKS node policies to talk to the EKS service, and CNI policies to the networking related permissions, and CSI, EBS CSI driver policy. EBS CSI driver policies, because AWS EKS can use EBS values for your Kubernetes pods to deploy any stateful applications. You need a value. You can use EBS values as a values to your Kubernetes pods, and there is something called storage class in Kubernetes. So by default, there is a storage class. EBS storage class will be created in EKS, but due to recent changes in the Kubernetes, you need to deploy CSI drivers also, and that CSI drivers require some EBS policies permissions. So we need to attach this EBS CSI driver policies also. You need to create one IAM role for worker nodes with these policies. Then I will create a node group, that worker node. So I have not created that IAM role. So let me go back to IAM. First create IAM role. Let me create IAM role. Roles. Create role. This time when I am creating IAM role, this time I am selecting use case as EC2, because I want to attach this IAM role to the node group. Node group is nothing but your Kubernetes worker nodes. That worker nodes are nothing but EC2 only. So I am selecting use case as EC2, but I will attach all these 4 policies. As per my current requirement, I am attaching all these 4 policies. If required, you can add other policies also. So let me type EKS. Let me select EKS worker node policy. Clear this filter. Let me type container registry. I will select this Amazon EC2 container registry read only. This Amazon EC2 container registry read only. I have given this policy's name here also. You can type, copy, paste, and search there. And I will clear the filter. I will attach CNI, container networking interface, this Amazon EKS CNI policy. Select that, clear, and EBS CSI driver. The CSI driver policies basically creating volume, attaching volume for that EC2 instances. This policy I need to select. Click on next. With these 4 policies, I am creating one role. I am giving that role name as EKS node group role, or worker EKS worker role. Let me create a role. Guys, whatever I am doing manually, right? Whatever I am doing manually, can I do all these things in the Terraform automatically, infrastructure as a code from beginning, also creating a VPC with required subnets, route tables, creating a IAM role for EKS, and creating a EKS cluster, creating a IAM role for node groups, creating a worker nodes also. Till here you can do using Terraform, right? Everything you can do via Terraform also. And now I am doing manually. So I created a IAM role. For worker nodes. Let me go back to my EKS cluster. Let me go back to my EKS cluster. Let me go to compute. Let me add a node group. I'll say demo EKS something node group. Now you need to select that IAM role, whatever I just now created, worker role. Let me go to next. Here AWS is providing some AMIs, optimized AMIs for EKS. So leave with the default only. There are only Amazon Linux and Bottle Rocket AMIs. So optimized AMIs for EKS worker nodes. And For now, I am going with very small capacity. That worker, that node group, I am selecting instance type as t3.medium, very small. But this one, it's up to you. It's up to you in real time what type of nodes you want to create. That node group, that node group, right? That node group has to be created with what type of instance. If required, you can go with very high configuration servers like this also, like 124 CPU, 256 GB RAM, based on your requirement, right? You can go maybe 64 CPU, 128 GB RAM, like that. For now, I am going with very less, very less. That is T3 dot medium. I am going just for demonstration. So I'm creating a node group with this instance type, and the disk size is 20. Node group size. So at any point of time, I need two servers. If there is if any parts, if there are any parts which are in a pending state, there is something called cluster autoscaler. I am not explaining all those things. If you deploy a cluster autoscaler in this EKS cluster, if you deploy a cluster autoscaler in this EKS cluster, if any parts are in a pending state, it may scale the cluster. That cluster autoscaler can adjust the cluster size. So we already discussed all these things in a DevOps in detail. I am not explaining what is cluster autoscaler, how to deploy, and all those things. So when you have a cluster autoscaler deployed, it can scale the cluster size also. That node group size also it can scale. So at any point of time, there will be two nodes. But if any parts goes to the pending state because of no resources available like CPU and memory, if you have a cluster autoscaler, it can adjust the desired size. It can scale the cluster. That is, I am defining the group size, like minimum 2, maximum 5, like that. Click on next. And this is where you need to select the subnets, under which subnets you want to create your worker nodes. So I will select only private. I will select only private subnets. So my worker nodes will be created in a private subnets. Suppose if you want to SSH, if you want to SSH to the worker nodes created for this EKS node group, you can enable this configure SSH access, and you select the security group all like this. So only I mean to say, port SSH port is open for all the IPs. If you select all option here, if you select all option here, whatever workers are getting created for that worker nodes in the security group, port 22 is open for all the sources. That is what the meaning of all here. So let me click on next. Key pair. In case of if you want to SSH, what is the key pair? Let me select this. Next, create a node group. So node group is nothing but one auto scaling group in the background. Node group is nothing but one auto scaling group in the background. So I have a EKS cluster. I have a EKS cluster. That EKS cluster, I added one node group. So after some time, you can see two nodes. Guys, if required, you can add multiple node groups for same EKS cluster. Suppose you need different types of instances in a same cluster. Suppose you need some some type of other type of instances like compute optimized instances or storage optimized instances also. You can add a multiple node groups for same cluster with a different instance types. So it is not like only one instance group, one node group. If required, you can add multiple node groups also to the same EKS cluster. So that node group is getting created. The node group is internally one auto scaling group. That node group is internally one auto scaling group. So that auto scaling group will create a worker nodes, and it will manage the worker nodes. Those nodes will be automatically joined to the cluster. Those nodes will be automatically joined to the cluster. If I go to EC2 section, if I go to EC2 section, I can see two nodes will be getting created here automatically for that EKS cluster. If you see this T3 dot medium and this T3 dot medium servers, I mean to say this one, these two, T3 dot medium and this T3 dot medium. So who is initializing these servers? I am not creating. So these are created by auto scaling group, but that auto scaling group is internally created when I added the node group. I have not created auto scaling group, this auto scaling group. This auto scaling group is internally created by EKS when I create a node group. So that node group is nothing but one auto scaling group. Now I have a EKS cluster ready. I have a EKS cluster ready with one node group with the two nodes basically. Minimum I have given two nodes. So this is how you can provision the EKS cluster. Is everyone clear what is EKS? How to create EKS cluster? All these things till here. Provisioning the EKS cluster. I can do this using Terraform also. Infrastructure as a code. So I can define everything as a resources. VPC resource, subnet resource, IAM resource, EKS node group resource, like everything I can create as a infrastructure as a code using Terraform also. I will explain that when I go for a Terraform. But is everyone clear what is EKS, how to create a EKS cluster? But once the EKS cluster is provisioned, it's up to you. What you need to do as a DevOps guy or as a developer or whoever it is, you can connect to the EKS cluster. You can connect to the EKS cluster and you can start deploying the applications. Whatever applications you want to deploy. You want to create some deployment, stateful sets, replica sets, ingress rules, services, whatever you want to do, you can do. Clear, everyone? Is there any limitations to create a worker nodes? There is no limitation. There is no limitation for any creating any worker nodes. You create whatever type of instance. That node group, when you are creating a node group, you are specifying minimum how many, maximum how many. As per your requirement, you can say minimum 50 nodes, maximum 100 nodes also, like 200 nodes also. Again, each node, what type of instance. I selected T3.medium, you select whatever is required for you. But you need to understand EKS concept there. It is nothing to do. It is nothing to do with Terraform. You should know what is EKS. But since I thought of explaining the services, that's why I'm explaining in detail all these services. Otherwise, if I directly go Terraform, I'll just explain Terraform only. But I thought of explaining this one also so that you can understand some idea. Nothing to do with odd number, even number for workers. Guys, don't bring a Kubernetes concept here. So you should have a Kubernetes knowledge. I will not teach anything. What is pod, what is deployment, what is service, all those things. Okay. You should have a background of Kubernetes because this is Terraform course, not DevOps course. I can't teach again Kubernetes. Kubernetes itself will take 20-25 days. The guys who attended DevOps already, they know how much time it will take to understand Kubernetes. Now, just a last point, just I will connect to the cluster, otherwise it is not going to be a completed one. So I will connect to the cluster and I'll just deploy one application, that's it. So how to connect to the Kubernetes? If you have a Kubernetes background, there is something called client, Kubernetes client. What is Kubernetes client, guys? You don't know? It's a CLI, a command line interface. So that command line interface is internally going to talk to the cluster. So let me create one machine. If I don't have any machine, I'll create one machine where I will install and configure kubectl. Where I will install and configure kubectl. So this can be any type of server. Guys, if required, I can configure in my local laptop also. If I have a kubectl installed in my local laptop, I can configure kubectl in my local laptop also. So why to create server? Why to waste the time? Or okay, that is fine. Maybe let me create a server. If you find it difficult to install kubectl in local laptop, you can do that. Let me create one server. Just some server. I'm just giving tag as a Kubernetes client server like that. This can be any other server like your Jenkins server also. So let me create one server. Let it be in any VPC. Let it be in a default VPC with public subnets also, because I have created a cluster endpoint access as public and private. Let it be in any VPC. So let me SSH to that server. Once the server is created, let me SSH to this server. I will install kubectl. With the help of kubeconfig file, I'll get the kubeconfig file and I'll talk to the cluster to deploy the application. Let me connect to this SSH. This is in any other VPC also fine, because I have created a public and private endpoint access for my API server. It will work. Let me SSH to this. I will configure kubectl. I'll configure kubectl. I'll install kubectl and I'll configure kubectl. So kubectl is a CLI to interact with the Kubernetes APIs. So I will install kubectl in Linux because this is a Linux machine only. So let me download the binary. Let me install that binary. Now I have a kubectl installed in this system. You can see kubectl version -- client. Kubectl is installed, but if you just install kubectl, it will not work. You already know Kubernetes concepts. So what this kubectl is internally going to expect for talking to the cluster, if you see, it is not working. What this kubectl is internally required, guys, the guys who attended Kubernetes sessions, what this kubectl is internally required to talk to the cluster. You need to configure this kubectl, that kubeconfig file. You need a kubeconfig file. But this is a managed Kubernetes cluster. This is a managed Kubernetes cluster, not self-managed. So you don't see control plane nodes. So how to get the kubeconfig file for this EKS cluster? You need to use AWS CLI. You need to use AWS CLI. So there is a command which you can execute to get the kubeconfig file. AWS CLI, AWS EKS, copy from master. Where is master Manohar? Manu, where is master? I can't copy from master. In real time, you will not get access to the master also. You will not get access to the master also, and there is no master here in this account. I can't copy from master. So with the help of AWS CLI, I'll get the kubeconfig file. So there is one command, AWS EKS update kubeconfig -- name, your cluster name. What is my cluster name? Let me see the cluster name. I have given something like demo EKS. This is my cluster name. I'll give, and -- region. This is in AP South 1, this cluster. But I don't have a AWS CLI. I don't have a AWS CLI. It will not work again. AWS command not found. So let me install AWS CLI. Let me install AWS CLI. That again, one CLI to interact with AWS, command line interface to interact with AWS. So I am using Linux only. So let me download and install AWS CLI. And again, if I just install AWS CLI also, it will not work. You need to configure AWS CLI. AWS CLI again requires permissions, AWS permissions. So with the help of master machine access keys and secret keys, I will configure. With the help of master machine access keys and secret keys, I will configure this AWS CLI. So master has a full permissions. Master has a full access. So it can talk to the AWS and get the kubeconfig file. So let me install AWS CLI first. I have installed AWS CLI in this system. but I don't have AWS CLI configured. Authentication problem will give. You need to authenticate with AWS. Your CLI has to authenticate with AWS. That is where you have some concept called IAM. As of now, I am going to use master machine access keys and secret keys. Sorry, not master machine. I mean to say this root user access keys and secret keys. So I will go to this security credentials. I'll generate access keys and secret keys. If you already have this access keys and secret keys, you can use. Otherwise, you can create a new access key and secret key. You can create a new access key and secret key. Suppose if you already have two and you lost, what you can do, you can delete. You can delete something like this also, and you generate a new access key. So I will use this root user access key. This root user access key, I will configure AWS configure access key, root user access key. I am copying the secret key. For future reference, you can download and keep it. 1 second. It is not copied. Yeah, correctly copied only. So everything I clicked on this, or you can click here and copy paste. Default region, I am saying AP South 1A, and preferred output format table or JSON, whatever. Now I have configured AWS CLI, AWS STS get caller identity. If you see AWS CLI, 1 second, there is a typo. AP South 1, guys, region, it is just 1. So let me reconfigure AP South 1. It is not 1A. So let me reconfigure AP South 1. Now if you see, I configured this AWS CLI as a root user access key and secret key. Root has access to all the services. So let me get the kubeconfig file. I got the kubeconfig file into this system in that default .kube directory. So that kubeconfig file has the cluster details, user details, as a which user it has to talk to the cluster, where is the API, that cluster that server, this endpoint is nothing but your API server endpoint. All these things are there. Now I can talk to the cluster. Let me see, kubectl get nodes, sorry, kubectl get nodes. It is having 2 nodes, and as of now, default namespaces, there are 4 namespaces. If required, you can create a new namespace, kubectl create ns, something like this, and you can deploy some application. You can deploy some application in that namespace. As of now, nothing is there. I'm just going to deploy some application, demo app. I'll create a deployment. I'll just take some existing YMLs, guys. I'm not going to explain again everything here. So let me take some deployment YML, service YML. I'll deploy that application. Let me take some application YML. Now let me whatever. So I'm not like you already know what is deployment and all those things. I'm just creating a deployment in this namespace, service in this namespace, and I can create a service of type load balancer also. So it will create one external load balancer. It will create one external load balancer for me. But let me remove all these things I'm not using. Line number 19 to 28 I will delete. So let me deploy this kubectl apply -f, just some sample application. So I got a deployment in that cluster with the 2 pods, 2 replicas. with two pods, two replicas, and there is a service of type load balancer created. I can access that application. I can access that application via this load balancer. In the AWS, it has provisioned the load balancer. If you go to EC2 section, the Kubernetes, that EKS has provisioned the load balancer. This is, we call it as a deployment. It is not infrastructure. Infrastructure is your EKS. Infrastructure is your EKS cluster. Once this is provisioned, once EKS cluster is provisioned, you will start deploying the applications. That applications deployment can be via pipelines or whether your developers will connect to the cluster. It's up to you. So let me show that. Automatically, one load balancer is created in that region. This is the load balancer. Via this load balancer, you can access that application which is running in your Kubernetes EKS cluster. So this is my load balancer endpoint and my application context. I'll give my application context. This is my application context. Now this application is hosted in the Kubernetes EKS cluster, and my application is up and running. And it's created a public load balancer in the public subnets. Anyone can access. This is just a deployment in Kubernetes, nothing to do with AWS or Terraform. So let me delete, once this is done, let me delete the demo application I just deployed, and I am deleting again this application. Once your practice is done, you delete your EKS cluster. Once your practice is done, you delete your EKS cluster, but you can't delete EKS cluster directly. First, you need to delete the node group. First, you need to delete the node group. If you select like this and if you click on delete, it will not delete. It will not delete. First, you need to delete the node group. So go to the compute tab and delete the node group. Once the node group is deleted, then you can delete the EKS cluster. So I will explain how to create a EKS also using Terraform, but in the Terraform session. But is everyone clear what is EKS, what and all components are part of EKS, what is required in AWS for you to create a EKS in the VPC? So try to create a EKS, try to create a EKS cluster manually so that you can understand when I explain Terraform. Okay. Thank you. That's it for today. I'll continue tomorrow. Okay. Tomorrow we will discuss about one more important service, CloudWatch. CloudWatch. What is CloudWatch? We will discuss CloudWatch tomorrow. Day after tomorrow, IAM. Monday, I'll start actual Terraform. Thank you, guys. I'll continue tomorrow.